Okay, question 6. I've got a lovely log question here. Now just remember your rules of logs. They're very similar to your index rules. So you've got, say, x cubed, x squared gives you x5. So you've got x5 over x cubed gives you x squared. And so you've got x squared to the power of 4 is going to give you x to the 8. So what happens here is we've got a relationship between multiplying and adding. Yeah, we multiply and add. Here we've got divide and subtract, and here we've got a power and a multiply. And it's exactly the same with our logs. When we are adding our logs together, we can multiply the arguments. When we take our logs away from each other, we can divide the arguments, and when we've got a power, we can move it to the front of our log to make it a multiply. So let's just, have a look at that in real life then. Okay, so up here, like I said, you've got a third times that. So I can rewrite this right away as log 2, just now a base, log 5, 250, take away log 5, 8 to the power of a third. So I can move up the third up to here in the same way that multiply and power, very similar to this. We can start to now rewrite that. So this, I can do the sum, can't I? I can say, right, log 5, 250, again with our indices rules, I should know that 8 to the power of a third is the cube root of 8. Line here. So 8 to the power of a third equals the cube root of 8, which is just saying what times what times what is 8. So that's going to be 2. I've got a takeaway, so that means that I can do log 5, 250 divided by 2. Take away and divide, just like the exponentials. And likewise, if that was a multiply, so if that was an add, sorry, I could then multiply these. So that's your 3 rules right there. You move the front number to give you a power, same as this, power times. When you're taking away, you do your divide. If that was an add, you would multiply. That's pretty much, your log rules there. So I'll just write that again. That's log 5, that'll be 125. Don't forget my little equal signs. Thrown out at the end. And what does that mean? Well, I like to think on something that I always remember. So log base 10 100 is equal to 2. Something like that might just help you remember what you're doing with logs. And the other way I think on it is that 10 just moves over here. So log 10 of 100, it's kind of saying, well, log 10 of 100, 10 to the power of 2. That's kind of what I'm, do you know what I mean? That's you're moving it around. So you've just kind of moved your 10 over here to say, well, this is the same as this, so 10 squared is equal to that. So this is the same over here. It's a bit like, okay, I don't know what this answer is. If I move my little 5 around here to be base 5, it's like 5 to the power of what gives me 125. So that'll come out as 3. Because if I was to put a 3 in here, that would then make sense, wouldn't it? 5 to the power of 3 is equal to this. Yeah. So don't get too confused with your logs. You're just doing the opposite of an exponent. But I always think 5 to the power of what gives me this number. Okay. And this is maybe quite a nice. I've just rubbed this bit out. But this is quite a nice reminder of what's going on. 10 to the power of 2. And 10 to the power of 2 is equal to 100. Okay. So yeah. I hope that helps. There's a nice little 3 marks for that one. The only way they can kind of dress this up is putting in some x's and things. So you trinomial at the end, but it's the same idea where you need to know that this base in your log is the same as the base for the exponent. So in here you might end up with x squared plus 2x, and that's equal to something. That's the only way they can make it trickier, but it's still just these rules.